Hello and welcome back to section 2 here. We're in chapter 8 where we're talking about factoring. And in section 2, we're going to factor with the distributive property, or to be a little bit more specific, the reverse of the distributive property. Right? Last chapter, we used our distributive property to multiply a monomial and a polynomial. Like so, we took the 2x and we did the distributive property to it. 2x times 6x gave us 12x squared. And 2x times 8 gave us 16x. Okay, and that was our answer. Now, in this section, what we're going to be doing is we're going to start with the 12x squared plus 16 and figure out what to pull out. So instead of distributing something in, we're going to undistribute that something and pull it out. Okay? As you can see, that one way to factor a polynomial is to reverse this process. That's what I was just saying. Right? Factoring is finding all the small parts that were multiplied together to get the expression. Okay? So all those little things, the 2 times 3 times 3 times 5 times 7, whatever it is, all those little parts get multiplied together. We want to find all of those. Okay? So if I start with 18x squared plus 6x, we need to find the GCF of 18x squared and 6x. Okay. Now, some of you are not going to have to do this factor tree. That's fine, but we're going to go ahead and do it for the first couple anyways. The GCF, we're going to split into 18 and x squared. 18 is 6 and 3. 6 is 2 and 3. This becomes 6 and x. This is 2 and 3. So when I look at the fact that I can combine a 2 and a 3 for each of these, I know that my GCF is 6. Then if I look at the x squared and the x, think back to section 1, I said all you have to do is pick out the variable with the smallest exponent. So I know that my GCF is 6x. Okay? That means what I'm going to pull out is 6x. So I start with this polynomial, 18x squared plus 6x, and I'm going to take 6x out from both of these terms. So 6x is going to come out front with parentheses. Now, I'm going to do 18 divided by 6, which is 3. And if I had two x's here, x squared, that means there's two x's. I took one out, that means there's only one left. Okay? Then I'll do 6 divided by 6 to get 1. And if I had an x and I pulled it out, that means there's no more x's left there. So the factored version is 6x times 3x plus 1. Okay? Now, you don't have to write this part here, but if you just pay attention real quick, if I start with 6x times 3x plus 1, okay, look at this off to the side. When I do the distributive property, and distribute that through, I'm going to end up with 18x squared plus 6x. Those match, that means I factored it correctly. Okay? So there's a way that you can check your answer if you'd like to, but that's not necessary. Okay? So that's the first way in which we can factor stuff. Okay? So let's try this again on our second example. 18xy squared plus 12x squared y plus 9xy. So the first thing we're going to do is take a look at our numbers, 18, 12, and 9. The greatest common factor amongst all of those is 3, so that I know I'm going to pull a 3 out. Then if I look at my x's, I have an x, I have an x squared, and I have an x. The smallest exponent is x for the first, so that's what I pull out. If I look at the y's, I have a y squared, a y, and a y. Again, the smallest exponent is 1, so I can pull out just a y to the first. Okay. Now we have to go through and actually pull it out. 18 divided by 3 is 6. I pulled out the x, so it's gone. I pulled out one of these y's, so that means all I have is a y left. 12 divided by 3 is 4. I pulled out one of those x's, which means I have an x left, and I pulled out that y, so it's gone. 9 divided by 3 is 3. I pulled out one of the x's, I pulled out that y, so that's all that's left. And this is my factored form. 3xy times 6y plus 4x plus 3. And again, if you were to reverse this process and take and distribute the 3xy, then you would get right back to where we started. Okay? Hope that made sense. If not, make sure to ask questions. We'll be doing practice with it in class as always. Now, another way in which we factor using the reverse of this distributive property is called grouping. So I'm grouping terms, and this is only done when I have 4 terms in my polynomial. Okay? Only 4. I wrote usually used, but it's always when you only have 4. You can't do it with 3 or 2 or 5 or anything else. You have to do it with 4. Okay? And why it's called grouping is I take the first 2 terms, group those together, take the second 2 terms, and group those together. And then I'm going to do this reverse distributive property on this group. So if I look at 4xy plus 8y, I see that I can factor out a 4 and a y is what they share, which leaves me with just an x in the first term, because 4 divided by 4 is 1, the y's disappear, and all I have is an x. 8 divided by 4 is 2, and then that y came out, so all that's left is x plus 2. Okay? Now in the second term, I see that I can pull out a 3. 3x divided by 3 is just x. 3 divided by 3 is 1. 6 divided by 3 is 2. Okay? Now, very, very important, when I'm doing this grouping, these parentheses that I just underlined have got to be the same. If they're not the same, one of 2 things happened. Either you made a mistake, or the polynomial is not able to be factored. So those are not the same inside the parentheses. After you factor stuff out, you made a mistake or it's not able to be factored. So the first thing you should check is to see if you made a mistake. Okay? Now, to finish this, what I do is I take what I pulled out and put those together. 4y, and it was a positive 3, so I'm going to put those together. Then I take the x plus 2's and just write that one time. And this is my final answer factored form. Okay? If you were to go through and you foiled that, so I did first out, inner, last, or you did the claw method, or you did the chart method that I showed you, you would end up with 4xy plus 8x, or sorry, plus 8y plus 3x plus 6. Okay? Again, not necessary, but you can always check yourself to make sure you did it properly. Okay? All right, on to the back. I know I'm moving fast, but there's a lot to get through. So please feel free to pause it, rewatch it, ask me as many questions as you can in class. Okay? So again, we're going to have 4 terms. So I group first 2 and last 2. Okay? Now, if I look at 35 and 5, I know that the greatest thing I can divide those both by is 5. If I look at x and xy, I know I can pull out an x. So I pull out 5x. 35 divided by 5 is 7. That x is gone. Minus 5 divided by 5 is 1. The x is gone, which means I only have a y left. Okay? Now I look at my second term. I can pull out a 3, and I'm left with y minus 7. 3 divided by 3 is 1, which leaves me the y left. 21 divided by 3 is 7. Now, what did I say has to be true about those 2 parentheses? I said they had to be the same. These are not the same. 7 minus y and y minus 7 are not the same. Okay? So here's what I need to do. I need to go back and take a look. And you always keep your first parentheses, the first set here. Okay? So this stays, 5x and then 7 minus y. What you're going to do is see if you can change the way that you do the second set of parentheses. Okay? So instead of pulling out a 3, the only other thing I could pull out is a negative 3, because I can divide them both by negative 3. Let's see what happens if I pull out a negative 3. 3 divided by negative 3 is negative 1y. Negative 21 divided by negative 3 is a positive 7. Okay? Now, if I take a look at the parentheses again, and you think about this just a minute, this can be rewritten as 5x times 7 minus y, negative 3 times, now this can be rewritten, since it's addition, as 7 minus y, positive 7 and negative y. Now my parentheses match up, and my final answer can be 5x minus 3 times 7 minus y. Okay? Whew. Lot to get through. So it's very, very important that those parentheses match up. If they don't, you have got to go back and check. So do the first set of grouping. Try to make the second set look like the first set. That's the key. Okay? So, quick summary here of what we've done in this chapter, or of this section. You can use the reverse of the distributive property anytime. What I mean by that is you can use it on any number of terms, whether there's 2 terms, 3 terms, 4 terms, 5 terms, 6 terms, 100 terms. You can always use the reverse of the distributive property if there's something that every single term has in common. Okay? In order to use grouping, you must have 4 terms, okay? Terms with common factors to group. So after you put them together and factor it out, those 2 sets of parentheses that I said have to be the same. That's what I mean by the common factors to group. The parentheses afterwards have got to be the same. Okay? And the 2 common factors are identical. It's another way of saying that also. All right? So there's section 2 for you. Factor with the distributive property, where you're going to pull out the greatest common factor and see what's left. Then you can also factor by grouping, where I group the sets of 4 into 2, and then use the reverse distributive property. Okay? Coming up in section 3, we're going to talk about factoring quadratic trinomials. And I know that sounds really big, but a quadratic trinomial is not all that big at all. All right? So, good luck. See you in class. Bye.